Hi students, this video is about states of matter and particle theory. Scientists say that every matter around us is made up of particles, and there are three states of matter. Number one, solid. Number two, liquid. And number three, gas. They say that all these three states of matter, they're composed of tiny little particles. If we have a look at these particles, these are the particles of solids. Right? If you can see, they are closely packed together. They vibrate at their fixed positions. They have very strong forces of attraction between them, right? And because of those strong forces of attraction, and because they have almost zero spaces between them, the solids are incompressible. Whereas if we have a look at the liquids, these are the particles in the liquid. They move freely, but they cannot be compressed. They have a definite volume. They have forces of attraction, but the forces of attraction are weaker compared to solids. And because of these weak forces of attraction, liquids can flow, right? But the forces of attraction are not too weak to fill the container, which is the case in gases. See, the forces of attraction are too weak that they roam around inside the container, and they can fill up the space, whatever is available to them. They have almost negligible forces of attraction. They have large air spaces between them, which is the reason that they are very easily compressible. Liquids and gases can also flow, right? Gas particles are the most energetic. They have most energy in them. Liquid particles are comparatively less energetic, and solids are least energetic, although they do vibrate at their fixed positions. Now, what happens if we try to provide them some energy in the form of heat? The energy is transferred to the particles, converting the solids into liquids. What if I cool it down? Now I'm taking away the energy from the particles. They come back to their positions. Forces of attraction start developing again. And now they would vibrate at their fixed positions. They have converted into solids. Let's have a look at some examples of solids. See, you can spot many examples around here. These are some examples of liquids: oil, water, blood, mercury, milk. Now we know these all can flow. They are incompressible, but they do not fill up the space that is available to them. This is some example of gases: air, helium gas, ozone, carbon dioxide, water vapor. Right, let's go back to our simulation. Okay, these are the particles of solids. I'm going to provide them heat energy. The particles will get energy. They start to move freely and they get converted into liquid. Now, if we keep on providing them heat energy, the particles will keep on vibrating more. They get more and more energy. They would space apart, converting this liquid eventually into gas. What if we apply some pressure from the top? Now, gas pressure is the force exerted on the walls of the container. The more the number of collisions on the walls of the container, higher would be the gas pressure. Now, if you keep on increasing the gas pressure, at some point it becomes too high to burst the container. Now, these are the water molecules inside the container. If I try to cool it down, what happens when you cool the water molecules? When you put it in freezer, you are taking away the heat energy from them. The vibrations, they are going to become less. Forces of attraction start developing, and when they become strong enough, the water gets converted into ice. Right now you can see ice on your screen. What if you take that ice out of the freezer and put it at room temperature? Now the vibrations have started to become more. The particles, they take heat energy from the surrounding and they would escape the forces of attraction. If you keep on providing it more energy, for example, put it on a stove, the particles are getting more and more heat energy. They would escape the forces of attraction, eventually becoming a gas or steam. See, at this position, they are getting converted from liquid to steam. Now, what are these transitions called? We have solid to liquid to gas. These are the three state changes. Let me change the color. Conversion from solid to liquid is called melting. Conversion from liquid to gas is called evaporation, also boiling. Now, the conversion from liquid to solid, let me change the color. Conversion from liquid to solid is called freezing. From gas to liquid is called condensation. Right? Sometimes solid gets converted into gas directly and it surpasses the liquid state. This is called sublimation. And sometimes a gas gets converted into solid directly without passing through the liquid state. This is called deposition. Right? This is the phase change diagram. Let's go back to our simulation. We have water. You take away the heat energy and the water gets converted into solid ice. This is called freezing. Now when you provide them heat energy, the solid ice becomes liquid. This is called melting. And if you keep on providing heat energy to the water particles, they get converted into steam or water vapor. This is called evaporation or boiling. And then conversion of steam back to water is called condensation. I hope that's clear.